Alright, unfortunately I have to do a little bit more about programming. I'm gonna have to push a little bit farther on the variable side. There are different types of variable types that we have to kind of push through. Um, and it's a boring topic, but yeah. Okay. So basically in the Hex Editor here for Hex HD, they are showing you probably all of the common types that you will encounter in the wild. Um, Sometimes people will make their own custom one, but this is the most established ones that you'll find out there. So I just want to mention those. They're worth mentioning at least, maybe not going over each one of them, but just mentioning them. And I'll be going over them a little bit in the programming there. So of course I've already talked about the integers, and we have different sizes of those, so I'm not going to cover that again. We have characters. A character, for example, if I click over here, I can see it says XGS, right? We can see that in the text side, right? Over here it says it's 88, right? Which it is in hex, it's 58. Converted into decimals, 88, right? But it's also showing you the English character as well here, which you can clearly see here. But you can also see what it is as different encodings, such as if it was a wide character, if it was under the UTF-8 standard, and it doesn't have the Unicode, but this would have been the Unicode here. Okay, so these are just text encodings, these three here. Okay, which we're not really going to be dealing with. If you can see it here in the text decoding side, then that's probably sufficient enough. I can see here it says, geo both C torso pelvis, right? If I can't read it, then that probably means it's in some special encoding in some other language that I don't understand. So either way, it's going to be impossible for me to understand. Even if I seen something in Japanese, I would have no idea what it said. So these are, for the most part, not going to be relevant. If you can see it here, then that's, you've found it. If you're not seeing it here, then you're pretty much boned anyway. So this interpretation here doesn't really help much. Flow points, I talked about a little bit, but we'll get into a little bit more. Basically, they store a fractional number, so you can store not just a whole number, but like part of a number, like 1.5 or something like that, that kind of stuff. These are encoded, so you can't just see it in the hex editor. Some of these I can recognize if I click on like here. This comes out to 1, right? So this representation 00803F is the value 1 in an encoded float form. Whereas if we look at the 32-bit integer type, we get like an astronomical number. All right. So some numbers are encoded differently, and this is an example of one. This is the number 1, but it looks nothing like the number 1. It contains 80 and 3F. Like, what? So that's a float point. A float point, like if I change this to a 4 here, this float point now is 0.75. So it's a very powerful data type that allows you to store fractions. So this is very relevant. Counter them a lot. So here you can see it's called a single, and here it says a float 32, and that means it uses 32 bits, which is the same as int 32. It uses 32 bits, so that's 4 bytes. So you can see here as I click on this, it highlights it over here on the hex editor side in blue. Okay, so double, which is a 64-bit, is going to be obviously double that, so it's 8 bytes. All right, that's a float point. And then we have down here, these all have to do with timestamps. So earlier on, somebody just conceived or came up with the idea of how to store time, and that is just to count the number of seconds from whatever point that they decided to start counting from. It's a really bad system. Yeah, it's a terrible system. So you first have to declare a data type, which usually they're going to use one of these integers, and typically used a signed integer typically. Okay, and they just start counting seconds. 1 second, 2 second, 3 second, 4 second. From I think from 1970, around there, 1970, 1960, around there, they start counting time. So if we type, we put this here where there's a bunch of zeros. This one goes to the 1600s. Holy shit. You can see here this representation here. It says 1601. This one says 1899, and this one says 1970. Yeah, so they're all over the place. They're very arbitrary. Somebody just pulled a number out of their ass and said, we're going to start counting seconds from this date. And they just kind of assumed that by the time the counter ran out of space, they were going to be dead and nobody would care anyway. So we have a thing where we've defined 4 bytes. We can't go beyond 4 bytes, and we're presented a maximum number that can be stored there, which is okay for storing dates for a certain amount of time, and then you run out of space. So what happens when you run out of space is a thing called overflow, where the number gets too big and it basically goes over to the next area. So basically this number is going to write into the next area. Okay, it's overflowed from where it was supposed to write from. That causes a lot of problems. So if it's a chip, well, everything's a chip. So if you have a chip in memory which doesn't have anywhere else to go, it will just crash. Shut down and crash because it doesn't know how to deal with that problem. Or what you do is you overwrite something that was really important that was next to it. You know, and if this is this whole thing, and if you remember this Y2K, when I was a kid, there was a thing called Y2K. They thought, oh, the computers are going to crash and we're all going to die, because they were storing dates, I think, into 2 bytes or something stupid like that. 16-bit era, and everything was in 16-bit space, and they were worried that the overflow would cause problems. So it's the same problem. I don't know what genius came up with this timestamp, but they count the seconds from a certain time period. Okay. Now timestamps are not important to us when we're talking about models, but you can see here a bunch of and you're probably wondering what is all this stuff. This has to do with timestamps. They are important, honestly, especially when you start dealing with managing data and wanting to store timestamps. Timestamps are really important for accountability reasons. So when you're talking about data files in general and storing and managing data, this is really important. But for the purposes of models, all this stuff down here, you ain't gonna use it. So don't worry about it. But I thought I would explain it to you guys. Okay. The last 3 things here are disassembly. Basically, we're talking about different types of architectures. CPUs and architectures are how things are designed, and there's a standard to it. Okay, and there's basically x86 is the design, and there's a 16-bit version, a 32-bit version, a 64-bit version, and they can store instructions. And these instructions are what tell your processor what to do. So if this was some sort of executable code, this instruction would give us different registers, and if you knew how disassembly worked, which I personally don't know a lot about it, you could look at the registers and you could reverse engineer the instructions by stepping through it and then building a map on how those registers work to make out a program. Okay, so these are actually the machine language, let's put it that way. This is what the instructions are saying in the code in the file. Okay, but we don't have any code here that's instructions. We have things that are either instructions, which tell the computer to do things, or you have resources like an image file or a sound file or something like that. It's not telling your computer to do anything. Your computer is going to be using the instructions to then utilize the resources. So we're dealing with models, we're primarily dealing with resources. We're not dealing with this stuff. Okay, but this stuff does play into the reverse engineering stuff, because you can then look at the executable, see how it's reading the resources, and then you can then read the resources through reading the executable and how it's reading the resources. But that's way past my capabilities. And then the last thing here is the byte order, which I didn't talk about, but it is relevant. Basically, based on the architecture of the CPU, the bits can be flowing from the left or flowing from the right. Right? You're probably like, okay, what does that mean? So when they're flowing in the opposite direction, the way that they're viewed in the hex editor is reversed. So that's why that's important. So for example, if I click on here, on this 15 here in hex, it's going to be like 30 something, or 21 in decimal, right? Okay. If I flip it, now it's like a completely different number, because it's in reverse. So it's completely different. So if I wanted to write the same number here, so this is a data type, and it's a 4-byte integer, so that's a int 32. So if I wanted to reverse it, I have to write it like this. Now when I click on the 32-bit integer, it says 21 again. You can see it's highlighted the space, and it's reading it reversed. Okay, so I don't know. I didn't research this ever. I don't know why they call it big and little endian. I don't know what the reasoning behind that is. It probably has to do with the architecture design of the CPU itself. It basically just deals with the way the bits are flowing in and out. So on some designs it flows left, and some other designs it flows right. That's all you need to know. That's going to affect how you identify numbers in a file. So when you're dealing with a file on a design architecture that's reversed, then you're going to see the numbers reversed. So the types of architectures or hardware designs which are using these reversed ones are like the Xbox and the PlayStation and all this kind of stuff. Back in the old days, they used to pioneer their own hardware. Today, they just use off-the-shelf components, so it's all the same. It's all a little endian now. But before, they used to be custom designed from the ground up, and they would, of course, they'd be designed a little bit differently. There'd be little quirks to it. So that's just one of the things you would see on like the Xbox and stuff like that. Okay, I apologize for that long-winded conversation about data types. I'm going to have to show a second part to this again because it's such an important aspect. But we've gone through all the technical ones. Okay, you don't really need to concern yourself with any of these. We're going to be dealing with obviously the floats and the integers strictly, so you didn't need to worry too much about it. But I thought these would be very important to communicate. Okay, see you in the next one.